This video will work through problem 5.7 from Gapenski's Healthcare Finance, 6th edition. Okay, in problem 5.7, we're presented with Grandview Clinic has fixed costs of $2 million, average variable costs of $15 per visit. So fixed cost equals $2 million, variable cost equals 15 per visit. So our total cost function is going to be 2 million plus 15V. Its sole payer, an HMO, has proposed an annual capitation payment of $150 for each of its 20,000 members. So we have 20,000 members and a per member per year payment of $150. Okay, so that's what that annual capitation rate of $150 represents. Past experience indicates the population served will average 2 visits per year. So the utilization rate equals 2. Okay, construct the base case projected P&L statement on the contract. All right, so if we have a utilization rate of 2 and we have 20,000 members, what that means is the number of visits we're going to get is going to be 2 times 20,000 equals 40,000. So we're expecting 40,000 visits. So that drives our base case then is going to be built around 20,000 members, 40,000 visits. Now our revenue is, in this case, is capitated. So that means we're going to receive a payment for the number of members that we have, not for the number of visits that they actually do. So how much revenue are we going to get? Well, we're going to get $150 per member times 20,000 members is $3 million in revenue. Now the variable costs, total variable cost, is going to be based not on the number of members per se, but on the number of visits and the number of and the cost per visit in variable costs. So 40,000 visits times $15 per visit gives us 600,000 in variable costs. Our contribution margin then, total contribution margin, is 3 million minus 600,000 or 2.4 million. And then our fixed costs are given as 2 million. So our profit then at this 20,000 member level is 400,000. All right. It next asks to sketch 2 CVP analysis graphs for the clinic, one with the number of visits on the x-axis and one with the number of members on the x-axis. All right, let's start with that. So let's get two CVP graphs ready, and the x-axis is number of visits and number of members. And so for the number of visits, which is more like what we've been doing, we remember we have fixed costs. Let's start with the costs. We have fixed costs of 400,000. So 400,000 fixed costs. Then we have variable costs of $15 per unit. So our total cost line is going to have a slope with $15 per visit slope, right? The difference between the total cost line and the fixed line is our total variable costs. And then, of course, up to the fixed cost line is fixed costs. And then our revenue now, here's what's different from what we've done in the past. Our revenue is not connected to the number of visits, right? It is connected to the number of members that we have. So it's a fixed amount, and it is a fixed amount equal to 3 million. So this is not going to be particularly to scale, but 3 million, 3,000 K is 3 million. So 3 million in revenues. So total revenue is a flat line. Why is it a flat line? Because as visits increase, revenue doesn't change. Total costs change. They keep on going up with each additional visit, but revenues remain the same. So what's different about this then? Well, remember, we want total revenue to be greater than total cost, right? Because that's when we have profit. If my revenues are bigger than my costs, then what's left over is mine, and that's my profit. So this is our break-even point, and this is our break-even volume. And in a fee-for-service arrangement, we'd be looking to go to the right? Because to the right of break-even, total revenue would be greater than total cost. But look what's happening here. To the right of break-even, when we have a capitated payment arrangement, capitated revenues, to the right of break-even, our total cost line is actually above our total revenue line. So that in this situation, total cost is greater than total revenue. Total cost greater than total revenue. So that is a loss, right? So to the right of the break-even line, we have the zone of loss. Over here, you can see to the left of the break-even point, our total cost line is below our total revenue line. So this gap, right, and all the points here up to the break-even point are profitable. So think about that. If I did 0 visits, I'd have $400,000 in cost because that's my fixed cost, but I'd have no variable cost. And if I did 0 visits, I'd still get $3 million in payment. So I'd make $3.6 million, $2.6 million, excuse me, in profit if I did 0 visits. And as I move to the right, I progressively have less and less profit until I hit the break-even volume, and then I just start losing money. All right, so now if we draw number of members versus cost and revenue, what changes? Well, we can assume, what we know, so we still have revenues up here and costs. So our fixed costs are still fixed, right, at 400,000. And as we increase the number of members, we know that on average, they're going to consume 2 visits. So the more members we have, the more variable cost we will also have. So the total cost line looks the same. This one might be a little steeper, but that's just because I draw badly, not because it actually is steeper. So the total cost line is actually still the same over here because the number of members drives the number of visits, and so costs still go up based on number of members. So it's really the same. The key difference here is because we have number of members down here, and it's number of members that drives our revenues. If we have 0 members under capitated rate, we get 150 times 0. If we have 1 member under the capitated rate, we get 150 times 1. So if we have 10,000 members, we get 1.5 million in revenues. And if we have, as is predicted, 20,000 members, then we get 3 million in revenues. So in this case, total revenue goes up because it is a function of the number of members, right? So we're back to looking like the fee-for-service CVP graph. And so we have break even again, just like that, just like this CVP for fee-for-service graph, except that fee-for-service, you would have number of visits as over here. All right, so then part C, what is the clinic's contribution margin on the contract, and how does that value compare with the value in problem 5.3? This is kind of a trick question, right? Because contribution margin per visit in this case is the number of revenue, the amount of revenue you get per visit minus the variable cost per visit. Well, how much additional revenue do you get per visit under a capitated contract? And the answer is zero. You get zero additional revenue per visit under a capitated contract. You get a fixed payment based on the number of members, not on the number of visits that you do. So your revenue is zero, and then your variable cost per visit are still 15 in this case. So your contribution margin per visit is actually negative 15. So for every additional visit you do, you lose $15. Let's see. So then part D, what profit gain can be realized if the clinic can lower per member utilization to 1.8 visits? Okay. So if we can lower utilization from 2 to 1.8, we would go from 40,000 visits to 1.8 times 20,000 would be 36,000 visits. So if we have, if we go back to our P&L, right, we have revenues of 3 million because we still have the 20,000 members times $150 per year. Our total variable cost, however, is going to be based on 36,000 visits instead of 40,000 visits. So that, I'm saying 40 and I'm writing 40, is 540,000 instead of 600,000. So our total contribution margin is 2,460,000. Sorry, 2,460,000. Our fixed costs haven't changed. They're still 2 million. And so our profit is 2.46 minus 200, or 460,000. So previously we had a profit of 400,000. Now we have 460,000. So if we can, our old profit, so if we could reduce utilization to 1.8 visits per member, we would increase our profit to 460, which would be an increase in net income to the clinic of $60,000. So it's definitely worthwhile for the clinic to work on reducing utilization under a capitated contract, which is what capitation is meant to do. It's meant to try to incentivize the provider to reduce utilization and save money for save money for themselves, right? And what we see in the marketplace is most often now some sort of sharing arrangement where if the provider can reduce utilization, then both the insurer and the provider share in the savings.